Hi Kimani, I hope you're managing to sort yourself out for the test on Friday. I just want to make a short video on parabolas just to try and explain this graph a little bit better and hopefully iron out any issues you might have had. So this is based off the work that was sent over those 3 weeks when people were sent home from school last term, and I'm just doing this to help clarify. So where are parabolas found in real life? Well, the only example I can think of are satellite dishes. So any signals that bounce in are reflected towards a focal point like that. So this only works for parabolas, not any other shape, not the semicircle, not half an oval. And it is possible to calculate where this focal point will be, but it's way beyond grade 10. So to start off, I'm just going to write down the general equation for the parabola that's in your textbook. It goes y equals ax squared plus q. So the two parameters that we're interested in are a and q. So to start off understanding how these parameters work, we're going to start off with the simplest parabola, y equals x squared. So I just want to get a few points and graph it. The x values I'm going to choose are minus 2, minus 1, 0, 1, and 2. When we put these values as inputs into the equation, it tells us that y equals x squared. So we have to square each of these points. Well, the first point, it's minus 2 squared, which is minus 2 times minus 2. The minuses cancel, a negative times a negative is a positive, and then we just multiply the 2's together, so we get 4, positive 4. Same thing for minus 1. We input minus 1, it becomes squared, and that gives us 1. Okay, continuing for the remaining points, we get 0, 1, and 4. So now I just want to graph this. X-axis, Y-axis, (1, 2), minus 1, minus 2. Okay, let's plot the first pair of points. Minus 2 corresponds to 4. So the x value minus 2 corresponds to a y value of 4. 1, 2, 3, 4. The next point, minus 1, corresponds to 1. So an x value of minus 1 corresponds to a y value of 1. And continuing like this, 0, 0, 1, 1, 2, 4. Now we can see our points here, and we just plot a line through them. Okay, the first parameter we're going to look at is q. So just to refresh, our general equation is y equals ax squared plus q. So we're going to keep a fixed at 1, and we're going to play around with the q parameter. So now let's look at the graph y equals x squared minus 1. So we're going to graph this, and we're going to use the same x values as for the standard parabola. So our equation is now different. It's x squared minus 1. So when we substitute minus 2, it's minus 2 squared minus 1. Minus 2 squared is 4, minus 1 is 3. Next point, negative 1. Negative 1 squared minus 1. So it's minus 1 squared is 1, minus 1 is 0. Okay, next point will be minus 1. Substituting 1, we get 0, and 2, we get 3. So what you might have noticed is that all of these y values are 1 less than all of these y values. And that makes sense if we look at the equations. This first equation is y equals x squared. The second equation is y equals x squared minus 1. So we do expect all the y values to be 1 less. Now, if we plot this graph, let's go through the points. X equals minus 2, y equals 3. Here's x equals minus 2, y equals 3, 1, 2, 3. So that's somewhere there. Next, minus 1 and 0, so it's there. 0, negative 1. Here x goes minus 2, minus 1, 0. So 0 for x is along the y-axis, and then y equals minus 1. Next, 1 and 0, and 2 and 3 again. Okay, so this second parabola has exactly the same shape as the first parabola. It's just that everything has been moved 1 down. So now what would we expect for the parabola y equals x squared plus 1? Here we would expect that everything is moved 1 up if we look at it in relation to the first parabola. So let's check with some points. So when x equals to minus 2, we substitute it in here. Minus 2 squared plus 1, that's 4 plus 1, which is 5. Next point, minus 1 squared plus 1. Minus 1 squared is 1, plus 1 is 2. And continuing like this, we'll get the points 1, 2, and 5. So we can see that all the y values here are 1 bigger than all the y values here, as expected. Now let's graph it. Minus 2 and 5. 1, minus 1 and 2. 0 and 1. 1 and 2, and 2 and 5. So once again, this graph has exactly the same shape as our original graph. It's just that everything has been moved 1 up. So next, we just need to talk about the turning point. So the turning point of the parabola is this point here, where the two branches meet. In our original graph, y equals x squared, our turning point is at the origin. So our turning point has the coordinates 0, 0. For the next graph, y equals x squared minus 1, everything moved 1 down. So our turning point will be 0, minus 1 over there. And for the last graph, the turning point will be 0, 1, which is there.